has brought in terms of security here. The question is answer is very simple, and it stands in the predefined methods and the way how we are encapsulating the list of queries that we may transmit from the client side into the database side actually. So sort of encapsulation, obfuscation, all of them actually sorts of raising up the security whenever you're communicating from client side to the database or database management system, or the vice versa, from the database management system into the client side. Client side, whether we are using a dedicated API or we are using the common API to communicate with the IDE, with the DBMS. Simple. So a small recap on what the properties that we can actually refer to in order to enhance the security, or let's say support, and let's say raise up the security level of all the transactions we may build, because the TSQL is concerned with building transactions, and those transactions, they are secured at a level. So to raise up the transaction securities, properties we have to adopt, and rules we have to obey, and policies we have to see in action in order to say that our transaction is secured enough. Amongst the properties we discussed, and still we are in actually the asset, the atomicity, consistency, isolation, and durability, which is a sort of group of properties how the transaction has to behave in different circumstances and different scenarios. That way it is to be secured. So that way it's a behavior. It's a scenario via which a transaction has to act in order to say that the transaction is secured. What does it mean? It means actually here a transaction service will be delivered, but to guarantee information assurance and to guarantee the security of the intact, the serenity of the transaction, we have to obey to those policies, those politics, those properties. No more, no less. The service, it's not the concern here of saying that the service has been accomplished or not. No, we are going to obey to the group of properties, because without obeying to those properties, a transaction might be accomplished. Without those properties, a transaction might be fulfilled. The service might be actually delivered. An end user might receive his needed or his needs, whatever he's acquiring as a service he might receive. Yet this is not the concern here, because whenever we talk about adopting those properties, in this example, the asset here, we're going to raise the security without harming the service that that a client might ask for. We will eliminate issues and frauds. We will not interrupt the services. Clear. There are pillars that they actually concerned as main properties to govern and rule the list of transactions. We'll define them one by them, and very quickly here, actually, just immediately. Let's take an example to make you understand, first of all, because actually when we talk about a transaction, you have to understand. It's not a query. A database means we are going to make a select or an insert or an update. It's a sort of a query to interrogate with the database or with a database management system. Simple. Unique tool to communicate with database is the SQL. This is a very common, and this is a primordial definition. But here we are seeing something different. We are not going to use the SQL as a tool to communicate. We are going to use transactions. And the transactions, they are a sort of a cover, a sort of, let's say, a scope, a blueprint, where queries are. Where queries are. This is what a transaction can manifest to us as end users or as developers. An example of a transaction, let's say actually we are going to, everything is digital, no, but a digital environment that would help a user to select a car, for example, to rent it, the selection here, and after the selection, he has to pay for it, and there have to be a key to indicate that he took the car and drove it out. All of this process is one transaction. So there have to be a car selection. There have to be actually confirmation and payment, and for the same car, for the same selected car, and at the same time, he has to indicate, or the system has to have a clue to indicate that the one who paid for the car has took it and drove it out. All of those queries, or let's say those steps, they are one transaction, one unique transaction. But by fulfilling them all, they dedicate, they design, they state, they specify that one transaction has been done. If one of those steps not be fulfilled, the full transaction would fail. Do not say that, for example, a user has selected the car and he took it. Okay, those are two he did, and one did not do. Okay, it's okay. Only one. It's okay. We can neglect. We can make the system run. No, does not go like that. The system does not understand that. This is one point. The second thing, this is not good, because if he does not pay, the car owner, he will not give the car. He will give him the car to go, to leave it, to use it, unless only if he pays for that. So the order first, second, third is one of the constraints. This is one of the considerations. In addition to that, they are all needed. We do not neglect one. It's not a matter of count. 2 out of 3, so it's good. We accept. No, completely we accept them all, or completely we neglect them all. How to obey that? How to obey to that? By adopting those asset properties. So now you clearly understand what is a transaction. This is an example only, just to bring your attention to that we are having more than one step, and all of them, they design one transaction. Here it's a very simple process, 3 steps to do. It's very simple to understand. But some cases, and so many cases actually, when we talk about professional work, we find actually tens of steps in one transaction. And we will see that actually when we talk about the isolation level. In this unit only, in this chapter only, we'll talk about the isolation levels, and the isolation levels we'll talk about so many steps to do, and we see examples of transactions that they have actually tons of queries to do. Let's say tons of steps to do, designing one unique transaction. One step further, let's take the example of the ATM bank to describe the asset process, the asset atomicity, consistency, isolation, and durability. The ATM process actually needs from a user to define, to authenticate himself versus an ATM machine. So the ATM machine has to check the account validity and the account balance, both. Who are you, and how much you have in your account. Check. Okay, you validated yourself, and you asked for an X money, an X value money. You're asking for 1, 2, 300,000 million riyals, for example, whatever the value is. The system or the account or the ATM machine has to check what you asked. Is it available or not? The value you asked. Is it exactly like the amount you have, or less? If yes, step 3 will come. Otherwise, no. It will stop you there. Saying that the amount you asked is available. You asked for, let's say, 10 riyal, and you have 100 riyal in your account. So, okay, it will be done, and it will give you money. The money will be withdrawn. Step 3, withdraw the money. So check first, and the amount you ask, it's available. So withdraw them. The machine will give you cash. After giving you the cash, the machine has in background, without telling you, it will update your accounts. What does it mean? It means the withdraw money has to be deducted from your account balance. It will give you the cash, yes, absolutely, but without telling you, it will deduct what it given you, the money withdrawn, the cash withdrawn from your account balance. It cannot give you money or cash without deducting the cash you took from your original account balance. So the process is like that. Let's talk about queries here. Queries, SQL queries to manifest this process. To check the balance, to check your account, is a matter of select profile of the user, select the balance in your money table, select. It's a matter of list of selects, even not only one select. Select the user profile and select the amount available in account. Okay, it's available or not, your account is available or not. Then account balance, to check, to read, actually it's again to read the value you input you want, and to select the amount you have in your account, and there will be actually an aggregate function in a select query to check if the value you requested is less than or equal to the amount available in your account. It's another select here. Good. Withdraw. It's a select from the account again. The update is an update. So here we are having different queries to use. Queries. Not only one query. Different and many queries to do. Saying that they are full. Saying that the list is full. One select here to check the validity of the account. One here to check the with one select to check the aggregate with one select query with aggregate method to check that the amount request is less than or equal to the account balance available. Withdraw, it's another select. Update, it's an update query. So here we are having 4 different queries. At least they are full, but they are more than full. All of them, they have to be executed, or all of them, they have to be neglected. Means to say that this transaction here has been succeeded, the ATM has succeeded, given money or cash to the end user, they have to be executed, 4 of them. 4 of them, they have to be executed. Otherwise, no, they have to be concealed, all of them. No update, no cash, no check of the balance, and the account has to be closed, terminated. In case of failure. This is an atomic view. Why? Because the atomicity, it's a manner via which we see a list of tasks to do here in this case queries. We see them as one. This is the atomicity. So atomic transaction means you have a list of queries to be executed all together, or not to be executed, or to be failed, let's say to reach a failure status all together also. Succeed altogether or fail altogether. This is the aspect of atomicity. Because if not happening like that, what does mean they are not atomic? Means that might be actually a reason to draw the cash without making an update. Yeah, you validate yourself, the amount balance is available, you receive the money, and an electrical shortcut. An electrical shortcut happens here. What does it mean? Means the cash you received and immediately shortcut happens. There will be no update. So if it's not atomic, خلاص, you took the money and the system will not update your account. You still have the money. It did not delete it. It did not deducted it. So this is a problem because of the non-atomicity aspect. But if the atomicity is applied, even if a shortcut happens here, there have to be a solution when the current comes back to update your account. It will continue because you took already the cache. You already took the cache. So there have to be a scenario to follow up when the current comes back or the system runs again later on after the problem. There will be an update process. It will not fail. It will continue later on. So this way, the atomicity is respected and it is deployed. At this point only, please, any questions?
No, doctor, thank you.
Okay, we continue. We continue. A very good example here to see to make you understand what does mean atomicity. Here, see, we have two queries to do: insert and insert. We are using the TSQL specifically to do the design this transaction. This is a sort of one transaction. We are setting it inside a procedure. Uh, two queries altogether to update one variable, two variables, sorry, variable one and variable two. They have to be either executed both or failed both. Why? Because we are going to execute the transaction from within the procedure body. We are not going to insert and then insert. No, no. We are going to make, sorry, we are going to call the transaction from within the procedure body. So either to execute the procedure or to fail executing this procedure. And the procedure has those two queries here. In this example, we are having two, but we might have more than two, three, 400, n queries. Either to be executed all together or to fail altogether. Why? Why I'm confirming that? No, it's not because I'm saying, because we are saying that they are atomic and we are executing one procedure here. See here, we're executing one procedure, USP. This procedure here, the name is here. It's user defined. It's user defined, USP, user defined sort procedure. Are you able to see here this example?
Yes.
Great, great. So here in this example, we're having two inserts only, but we might have select, select, insert, insert, select, update, alter, delete, data, what something like that. All of those queries, they are only defined in one procedure, one process, which is one transaction. The process will not stop, for example, after inserting this the values here for the variable one and stops here. No, it will not. It will execute this one and it will execute this one also. At the end, it would execute both in this example. And if there are more than two, then all would be actually executed. To what? To queries. More than two, all they have to be executed. Otherwise, all they will be actually failed because we are calling one procedure here. We are not calling two or we are calling a part or we are calling a query. We are executing a procedure. The full procedure body will be executed. Second property, which is the consistency and the context of being consistent in terms of terminating or finishing the transaction question. Because here the example we are having two queries only inside the procedure. But suppose that we are having a list of queries to do, a long list even of queries to do. What does it mean? It means actually we have a list of insert, 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 and select, select, and aggregate, select, aggregation, aggregate methods. We are having them inside the select queries, a list of similar queries, and would like to make actually an execution of a very short transaction in between. Should we stop this transaction, or should the system stops this transaction and executes the second transaction, then comes back to finish the transaction, the first transaction? No, because if he does, this is not consistent. He's not consistent. A full procedure has to be, sorry, a full transaction, not procedure. A full transaction has to be terminated, then we pass, or the system has to pass then later on to the next transactions. So consistency The second property, actually, it means that a transaction has to be fully executed, or from the beginning has to be cancelled fully. There has to be a solution how to forbidden to stop a transaction from being stopped midway. What does it mean? It means actually while it is being executed, the system stops it to execute something else, and then after comes back to finish it. No, this behavior has to be omitted. Actually, technically we can do, and it can happen, but if it happens, we are breaking the consistency fact. If it happens, there is no consistency, because there is actually some security measures here that would be broken once you stop the execution of a transaction in midway. If you let a different procedure, a different transaction to happen, to be executed by your processor while another transaction is being executed, so you are exposing a transaction content to an external, let's say, environment, whatever. So consistency means a transaction has to be fully executed from the beginning till the end, until the end, without being stopped or interrupted. So here we are eliminating the inferences or interceptions. We are eliminating them. Even if the transaction is very long, here when we say long, it's not in the human count, because for us humans to execute a query we need time, but for a computer to execute a query, it's a very short time. To execute hundreds in plural of queries, it is a short time. Yeah, absolutely. But even though if we have a very long list of queries to execute or steps to do from within one transaction, fully it has to be executed, then after next transactions would be put into action. We do not have to allow to infer a transaction for any reason, whatever the reason is. Otherwise, if you do, consistency will be broken. Here does not mean if it has been stopped in between that it would cause an error, or actually it would be hacked. No, it is not. But it can be yes or no. Both of the scenarios, they are still in question. But to apply the consistency and to obey to the consistency and to guarantee that the consistency is set, so inferences has to be omitted. Inferences or interferences, they have to be omitted. One question I'm ask you actually as true false question. A system that allow transactions to be interfered is inconsistent. True or false? The answer is true. A system that allow transactions to be interfered or inferred is usually failure. Let's say cause failure or reaches a failure. Usually reaches a failure. Answer is false. Answer is false, because if we do not respect the consistency, does not mean it's not a consequence that the system will fail. No. It might fail, it might not. But does it preserve the consistency? No, it is inconsistent. It is not inconsistent. It is not consistent. It is inconsistent. Is it clear, please?
Yes,
Great. Yeah, actually, just simply speaking, when I talk about the questions to define you, uh, and consistent system reaches let's say failure usually. Here the answer is false, absolutely. But the inconsistent system is due to inferences. Answer is true. You have to understand this aspect here. You have to understand this aspect here. Okay, the third actually property that we have to respect also is the isolation. What does it mean? As per the consistency, the transaction has to be fully executed without interference. What does it mean? It means we are not allowing extra or other transactions to be executed while a transaction is in execution mode. This is a sort of isolation. It means we are not going to allow any other inferences, any other interceptions. So we are isolating a transaction from the external environment. It has to be fully executed, otherwise fully failed, retrieved. How? By obeying and adopting the isolation, let's say, rules, in the sense of a transaction has to be given a channel to be executed by the processor from the beginning until the end. The scope of the transaction will not accept any other interferences. So this scope is isolated. This scope is isolated. Is it clear so far? Those are three properties that they are actually very crucial to secure a transaction. And once they are adopted, the atomicity, the consistency, and the isolation, once they are adopted, means they are actually set and fulfilled. This has to be for all sessions. Taking the example of the ATM machine or the ATM transactions, like all sessions, they have to be actually obeying to all the rules, the atomicity, the consistency, and the isolation. All sessions. What does it mean? For all customers, anybody tries to retrieve money, the transaction has to be for all users, has to be atomic, has to be consistent, it has to be isolated. User number one, user number two, customer number one, customer number two, customer number n. For all persons, men and women, everybody, small in age and elder people, new customers or old customers, all of them, all sessions, they have to be obeyed to those properties, all sessions. This is an example of durability, which is the fourth property from the asset, durability. It is not because you are a very old customer to the bank. For example, you are now reaching 10 years of loyalty with the bank. So you can, when you ask for 10 riyals and from your account, we give you 15. No, because you are old. No, no. Or because you are very new. You are very new. So the consistency, it will not be respected. It means the system will allow interferences or interceptions to your requests, to your transactions, to the transactions from your session. No. Consistency will be valid for all new customers and old customers. This is the durability. It has to be respected for all sessions. For the durability, can you repeat the definition I've given you, please? Can you repeat the definition related to this durability? Are you able to redefine what does mean durability? I'll give 2 marks in the final. Darshtain, if you can actually answer. Redefine me what is the durability. What does the durability mean? Okay, it's up to you. Continue. The summary here actually about this list of properties, those properties. The properties, they are actually sort of how the transaction would be executed and how the behavior would look like, the behavior of a transaction, how it would look like from within a system. Yeah, absolutely. But those are not the unique constraints to be considered. Asset, they are properties to be adopted. More than that, here we are defining the transaction modes. Transaction modes. Within the SQL server environment, transactions have modes of execution. What does it mean? Means we can use or we can call a transaction for a test only, not to commit, not to adopt it, not to save it. Means its results or its impact will not be seen from within the server side. It will be only for test purposes. So this transaction will not be fulfilled. This is not an error, but this is an execution mode. This is an execution mode. Execution of what? Of the transaction in question. We will see the result, and if we admit, we will commit. If we do not admit, we will execute. We will exit. We will not admit that. We will not commit that. Here we talk about the commitment of the execution. Transaction have one query or n queries, whatever the number of the queries inside the transaction. Either we are going to admit and commit that, save the result, or not. So we are going to see, visualize something like that, or not. And even this commitment here to admit, once we are required to commit, it might be conditional. It might be conditional. We are talking about the batch scoped transactions. In conclusion here, transactions, transactions in plural, they are having execution modes to specify when and how. When when you talk about the conditional execution, batch scope, and how, whether they are actually to be admitted at the end or they are implicitly admitted by the system itself. Transactions modes. We'll define that next class, inshallah. Any questions so far? Transactions modes.